So this is section 1.1, distance and midpoint formulas, graphing utilities, introduction to graphing equations. Introduction to graphing equations. All right, please only write the stuff down that you don't know, because we're going basic. It may have been a while since you guys have done math, so just to refresh, this is the rectangular or the Cartesian coordinate system. Thank you, Rene Descartes, for inventing this for us. The y-axis is the up and down one. The x-axis is the horizontal. The origin is at 0, 0. To plot a point, you always put x first and y second. So this would be 4, 5. 1. Quadrants start in where x is positive, y is positive. So this is quadrant 1. And then it goes left-hand side. It goes around counterclockwise. So it starts quadrant 1 here, quadrant 2 here, 3, and then 4. So counter the clock. So we're going to plot the point 6, 4. Once again, when you get to stuff you don't know, please write it down. The stuff you do know, you definitely don't have to write down. So we go over 6, up 4, and put the point down. So -3, -5 would be to the left 3 and down 5, plots a point. 0, 7 would be over 0, up 7. Lastly but not leastly, -6, 0 would be to the left 6, up 0. Here's our quadrants. Definitely make a note on this. This is something that it will come up on standardized tests a lot. Whether you're a 12th grader and you have to take an assessment test at the end of the year to get into your school, or you're taking your 11th grade and you have to take the SBAC test in the spring. Knowing your quadrants is an essential test question. So one element to note, that when you're in quadrant 1, x and y are positive. In quadrant 2, x is negative, y is positive. Quadrant 3, x is negative, y is negative. And in quadrant 4, x is positive and y is negative. Okay, so for everything graphing calculator, some of you guys are going to be really proficient on graphing calculator. Some of you guys it's going to be brand new, but it's important to be able to graph equations, and we can do that by plotting points on a screen. The screen of a graphing utility will display the coordinate axes of a rectangular coordinate system. Obviously, you're graphing x and y coordinates, it'll be x and y. So it looks something similar to this on your graphing calculator. The big component is scaling the axes. Sometimes you get, you go to graph something and you type in the equation and nothing is on your graph. It is not because nothing has been graphed, but because your windows are not scaled correctly. So this is called setting the viewing rectangle or viewing window. So X-min, X-max, X-scale. Pretty clear, pretty straightforward. The only weird one is the X-scale. That says, what do you want to count by? So if I want to count, if I'm looking at big numbers, thousands, and you have to really look at your problem and be good thinkers. If I'm counting in thousands, I make $1,000 an hour because I'm mega rich. I want to scale my x-axis in thousands, or my y, or hours would be. I could scale that by ones, but my money, my y-axis, I would want to scale by thousands. So now you guys are grown up enough in your math where we can start manipulating our viewing window. So it's the same thing, X-min, X-max, X-scale. You can do the same thing on the Y, Y-min, Y-max, Y-scale. Here's how it looks on the graphic calculator. And I could even pull it up, come on Desmos for you. It's under settings. Graph settings. So here it is. It's it'll let you change what you wanna, what your X-min and X-max could be, and let you modify what you count by. So then this goes from 0 to 100, counting by tens. All right. I'm going to skip to the distance formula because I think you guys have a pretty good handle on that. If you need more help, please see me. I'm happy to. Okay. So you guys saw this on your pretest. Find the distance between points 1, 3 and 5, 6. We're going to use a little Pythagorean theorem. That's where the distance formula is derived from, and that's how I remember the distance formula. Because Pythagorean theorem is a squared plus b squared equals c squared, the distance formula, since is the difference between the x's squared plus the distance between the y's squared. Let me get to here it is. The distance formula is subtract the x's and square it, subtract the y's and square it, and then square root. And that'll give you the distance between 2 points. I'll pause. I lost my tool. This one. All right, so no matter where you're at, and in fact, the order doesn't even matter. You just subtract the x's. I don't care which order it is because you're just going to square it at the end and take away that negative. I'm getting examples. Please note, if you have a horizontal line segment, it's the difference between, if it's horizontal, it's the difference between the x's. If it's vertical, it's the difference between the y's. Don't make it more complicated. So I want to show you an example before we move on to midpoint. We take x2, which is -1, subtract it from x1, which is 2, and square it. We take y2, which is 3, subtract it from -4, so 3 minus -4. Kind of important, and when I mean kind of, I'm saying that sarcastically, it is very important you keep your signs in order. Always a minus, and then the number as it's written. It's easy to get caught up and forget a minus sign or a negative sign, so make sure you're being diligent. Double check before you start crunching the numbers in. That simplifies to -3 squared plus 7 squared, which is 9 plus 49, which is 58, square root. Be comfortable. Sometimes the answer will look like this. Sometimes it'll be in approximate form. Sometimes it will be in simplified radical form. So if there is any way to simplify it, like if there's a square root of 32, that is 2, sorry, it's a root 2, no, forward, yeah. if you need to practice simplifying rational expressions, we can do that together, but it'll come up in multiple choice answers where it could look a couple different ways. Okay. I'm going to skip past this. If a triangle is a right triangle, what property can we use? Find a right triangle. He's a theorem. Old Greek guy. Starts with a P. I've mentioned him before, and this is very, yeah. Use the Pythagorean theorem. If a squared plus b squared equals your hypotenuse, you're a right triangle. So this problem is saying, find the distances. See if when you square them and add them together, you equal the hypotenuse. Nope. Even simpler, more simple than that. So if on these problems there is no other way to do to determine if the triangle is a right triangle aside from finding the distance between each of the 3 points, you got to do it 3 times. And just so you remember, the area of a triangle is 1/2 base times height. So when they ask you for that, make sure that you know how to do that. All right, midpoint. I love midpoint because the formula is simple. It's the average of the x's and the average of the y's, and it's a coordinate. So when it asks you for the midpoint, you should have a coordinate, x and a y. So it's a coordinate, x coordinate, y coordinate, average of the x's, average of the y's. Simple as that. Once again, make sure you keep track of your integers. This is -2 minus 5, which ends up giving us -7/2. 4 plus 2 is 6, divided by 2 is 3. They wrote it as a fraction here. I personally like writing it as a decimal, especially if you're graphing it on their graph. I want to plot that point, and I have trouble plotting -7/2. I would rather plot -3.5. All right, so you're going to be asked to graph equations by hand and plotting points. So whether it's a parabola or a line or a circle or whatever you have, if you're graphing it by hand, then I just make an XY table and plot the points. You don't have to get any more complicated than that. You're trying to do it quickly, and if you want just a quick sketch, read the directions, plot them. To determine if the points are on the graph, you plug in the x and the y and see if you get a true statement. For A, because 4 is not equal to 6, not a true statement. For B, -3 times -2 plus 0 is equal to 6, so it is a point on the graph. And then for C, 3 plus 3 is 6, so that is also a point on the graph. And if you plotted it, easily see visually. So making an XY table, if x is 0, y is 5, x is 1, y is 7. This is a quick and easy way to get a nice little shaped graph, plot the points, use a straight edge, go to 10. Parabolas are U-shaped. Sometimes they're on the y-axis, sometimes they're on the x-axis. Just be wary of each of those. All right. Now my favorite part is the graphing calculator part. And I think I've gone through all of them. Alright, so graphing utilities. To graph an equation in two variables, x and y, using a graphing utility requires an equation in the form of y equals. Now that is for your graphing calculator. For the online utility, it doesn't need to be in y equals. But if you have a graphing calculator, you need to solve for y before you put it in. So here you can, so if you have a linear equation, just put the y first. If this one's already solved for y. So this slide just goes over solving equations. You want to do the opposites. So if you have a y plus 5, to get the 5 on the other side, you subtract 5. And so on and so forth. If you have a times 3, the way to get rid of it is to divide by 3. So for example, I have 2y plus 3x minus 5 equals 4. We want to add 5 to both sides to get rid of the minus 5. We are going to subtract 3x from both sides to get rid of the plus 3s. And then lastly, we're going to divide by 2. So in our calculator, we would put 9 minus 3x divided by 2. I would include parentheses around the 9 minus 3x because your calculator is going to want to divide the 3x by 2 and not the whole numerator. If you get to a place where you're doing fractions, make sure you're putting plenty of parentheses in your calculator because it's very order of operations. It can't read your mind, it's a machine. So in this case, to solve for y, we would definitely put this in our calculator, subtract the 6x squared, and then divide by 2. Even though they changed it to 3 here. Please ignore. All right, one last thing. You can create a table of values using your calculator. So I'm going to show you how to do this on Desmos. So let me go back to change my settings back to the normal. So -10 to 10, step by ones. Okay. So if I have a nice little equation, here's my line, it's lovely. If I want to make it into a table, it converts to a table of values. And if you need more numbers, you can type in more numbers and it'll calculate it for you. Pretty nice, huh? A little different than the graphing calculator, but we'll forgive the graphing calculator. It knows not what it does. So you can do the same thing using the table functions on your calculator. You input the equation, you go to table setup, and then you can look at your table. It's at the top little line on your calc. To find intercepts, intercepts are when either x or y is equal to 0. I'm looking for. So what I do is I plug in 0 into my equation for x and find out what y is. That's the y-intercept, and then I plug in 0 for y and find what x is, and that's the x-intercept. Easy peasy, lemon squeezy. To do that on Desmos, all you have to do is click, and it'll tell you what the intercept is. So for this, the x-intercept is -2, 0, and the y-intercept is 0, 4. So you can always use graphing to verify that you've done your math right. Okay.